Hello and welcome to Advanced Algebra 2 Summer Bootcamp Round 2. In this video lesson, we'll be talking about combinatorics. It's not a very common thing to actually get to in Algebra 1. So in a way, this is not really review, but it is good to talk about because it leads to some nifty things and is actually good for some test prep as well. But we'll end up coming back to this later on in an Advanced Algebra 2 course. Now, the first thing we're going to do is not actually work with the calculator, so you don't need your calculator for this first part. We will, however, work with what a factorial is, permutation, and combinations. So just a few notes before we get started here. Well, we are getting started. Let's go. So let's talk about factorial for a moment. This is a necessary calculation in combinatorics. But it's really simple. It's just the product of a number and all of the integers below it. So n factorial, so n is a whole number. N factorial is equal to n times n minus 1 times n minus 2 times n minus whatever, all the way down to 3 times 2 times 1. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, but not 0. So 5 times 4 is 20, times 3 is 60, times 2 is 120. So in a moment, we'll learn how to do that on the calculator because once you get to some larger numbers, it gets to be way too big. Now, permutations and combinations are very similar, one in which order matters, one doesn't. So in permutation is an arrangement of objects in which order matters. So we have some ice cream. We have an ice cream example down below, and we're going to arrange the ice cream scoops on our cone in a specific order. Or we're going to put people in order, or we're going to use a password for our computer. The formula for this is NPR, such that n is the number of objects that we have and r is how many that we're choosing. Combinations is an arrangement of objects in which order does not matter. So we're selecting people for a committee, or we have a lock that we just need to get the numbers. They don't have to be in order. So an arrangement of objects in which order does not matter, and the formula for this is NCR. Now these NPR, NCR formulas are really basic. You'll see soon in this video what they actually mean, but it's a shorthand notation for what we'd use in the calculator. So let me show you those things on the calculator, and then we'll do the tree diagram towards the end here. So let's bring this down here and put this calculator thing up front, and you could get your calculator ready to join me in a moment. And we'll jot down some notes. All right, so I'm on the main screen here on the calculator, and we're about to do the same things we just did, but with some actual values. So we're going to do 5 factorial first. So on the calculator, let's press the number 5. And we're looking for the factorial, which is exclamation mark. 5. So math, and then go to prob down to 4, and then press enter. So a pretty simple calculation. It's just how many ways can you order 5 things? 120. And then let's do the 5 NPR, and let's say 5. So it's actually the same thing. We have 5 objects, and we're ordering all 5 of them, same number. So I press second enter now. What if I want to arrange just 4 of the objects? Well, that's actually the same because the last object would have been forced to be in the same spot. And then we could change it again just to see how these numbers compare. And so that's taking that second to last one, which would have been the 2. We're not arranging the 2, but we're arranging the objects. So we're going kind of quick here. Now we're jumping right into the combination just to see those numbers. So how many ways can you arrange 5 objects without order? It's only one. You just have them all. second enter, and then we'll do 4 objects. You might expect it to be the same, but it's different. So currently these numbers don't mean too much to us, but we're just kind of plugging them in to see what it's like and what type of numbers we get. But what I really want you to see is that 60 for 5P3 and 5C3, that 60 is way bigger than the 10, meaning there are more ways to order things in order, arrange things in order, than if they were out of order. And so the last thing I'm showing you here is if you press alpha window, that comes up with a shortcut for these 3 options down below, NPR, NCR, and factorial. So you could use that. You just have to have the most recent operating system for the TI-84. So if you don't get options like that, then you just need to update the OS, and you could do that by downloading a program that Texas Instruments puts out. Now let's do this tree diagram before we do the actual activity. So the question says, list all the ways to place ice cream scoops in a cone. And what this does is highlight the idea of putting things in order. So we're using vanilla, strawberry, and chocolate. So if you could jot this down like me, that'd be great. First we start with a point, and that's just a point at which we're making a thought, we're making a decision. So that point, and then we draw a line to vanilla, strawberry, and chocolate. So we made our first choice, and if our first choice is vanilla, then we're going to go down that part of the branch. Strawberry, we go down that part of the branch, and chocolate. So pretty simple setup. And then the next thing, so if we choose vanilla to be the bottom, so let's say vanilla is the bottom, then we have 2 options after that. We could either choose strawberry next or chocolate. Same goes for strawberry. We could choose vanilla or chocolate. And with chocolate, we choose vanilla or strawberry. But then our last choice is automatic, right? If we choose vanilla, then strawberry, the last choice is going to be chocolate. But what that does is it gives the individual possibilities under each choice that you make. You know, you go down one branch of the tree and you end up making a few choices that leads to a final arrangement. So what we see here is that we have 6 ways to arrange vanilla, strawberry, and chocolate based on just the letters that I wrote here. But the quick way to do that is we have 3 flavors. How do we arrange them in order? 3 times 2 times 1. First you have 3 choices, then you have 2 choices, and then you have 1 choice, or really no choice, right? So 3 times 2 times 1. The next thing we'll do is work through the problems on the Perms and Combs activity sheet together, and then you'll do the additional practice. You could try those out. So let's check out problem 1, this introduction. And I kind of already gave you an introduction, but in case you didn't remember, a permutation is a way of selecting objects from a set in which order is important. And therefore, number 2, a combination is a way of selecting objects in which order is not important. So let's think about this, the examples of permutations. What could be some possible permutations that we can think of? Things that we're putting in order and which, things that we're arranging in which order is important. So I mentioned password before. Another one I could think of is a license plate. You know, if an officer is checking out a license plate, then my license plate, even if it has the same numbers and letters as somebody else's, the order is important. So I hope I don't get the ticket versus that other person. Wonder if you're thinking phone number. That's a way to arrange numbers so that you call a specific person. Dialing 911 is different than dialing 119 for sure. And so combinations, even though you have a combination lock, that's not actually a combination, it's a permutation. So number 4 and 5 are kind of cool because we could get kind of artistic and visual with how we list out our possibilities. So with the shapes there, it's very similar to that vanilla, strawberry, and chocolate ice cream I talked about, except we're arranging 3 shapes. So we should still get 6 of them. And here they are. And what I want you to do for number 5, see if you could pause this and come up with a way to organize these letters on your own. So how would you organize it? So you have 4 letters, A, B, C, D, and we know that there are 4 factorial ways to order the letters because we're going to use all 4. But then it says try to find all of the ways. Now don't worry about that for math thing. It's actually entered, it's typed incorrectly, especially if you have a newer calculator. So 4 factorial, I showed you how to do that. So we kind of know the answer. 4 times 3 times 2, which is 24. So it's going to be quite a bit, so you got to write kind of small. So pause for that. All right, so here are all of my possibilities, the ways that I arranged those letters. And notice how I chose to do all of the A's first, and then the B's, and then the C's, and then the D's. A is so lucky, he's always first. Let's check out problem 2 now, horse races. Ooh, you're about to see why this is so popular, why horse racing is so popular to bet on. Now, here are the formulas for permutation and combination. Not important that we know these, memorize these at all, especially at this point in your math career. It's not until we actually study discrete math later in Advanced Algebra 2 or for students who take pre-calc later in pre-calc. But those are built into the calculator. So our focus is really using the calculator for this sort of thing. So number 6, in a race with 10 horses, how many ways can the horses finish? Now that box to the right is not for number 6. So think about it. In a race with 10 horses, how many different ways can they finish? This is every horse. Every horse. Okay? So this is actually 10 factorial. 10 times 9 times 8 times 8. All the different possibilities in order. And notice how, you could do 10 NPR 10, but that's the same as 10 factorial. Now number 7, how many different horses could finish first? Well, I believe there are 10 horses. So there are 10 horses that could finish first. Did you think about that? All right, I'll give you some time to think about this one, or you could pause. How many ways are there to rank the winning horses? In other words, how many ways can you arrange the top 3? So the first question to ask yourself, is it important the order in which these 3 horses finish? 1, 2, and 3. It says rank. And so therefore, should we use NPR or NCR? And the correct answer is NPR. So we would take all of the horses, 10 horses. We're choosing 3 of them. So we're arranging 3 of them. So 10, P, 3. And that's what that little screen is up at the top right. So when you type that in the calculator, you could see what you get for the total number, which is 720. That's a lot of different ways. So no wonder why the odds, like when you could pick 1, 2, 3 of horses, that people who bet on horses, they win a lot of money because the odds are way against them. Okay, this is the last problem we'll do together. Combination lock or permutation lock. So like I mentioned before, a combination lock really is a permutation lock unless it really doesn't matter the order. So I had a lock on my front door where you just had to make sure to press the certain numbers, like 5, 1, 2, 9. That's not my code, by the way. And then you just had to make sure to press those, not necessarily in that order. But usually locks are permutation locks. So look at the lock to the right. So that's the classic combination permutation lock, and it has the combination is 3 numbers with no repeated numbers, meaning you have to put in those 3 numbers. So this question, how many possible combinations are there for the lock? So no numbers are repeated. Now we could use a formula. We could use the NPR formula. The order matters. But really what we're doing here is we have 16 options for our first number. Notice. And then for the second number, we have 15 and then 14 because you can't use the previous number. So if we just multiply those together, it's called the multiplication principle of combinatorics, then we'll get the number of possibilities. Also, if we do 16p3, we would get that as well. Now, how many possible combinations are there for the lock in the problem if repeated numbers are allowed? So we choose a number, could be 16 or 12 or 9, and then we choose another number, but it could be the same one. So literally the password could be, or the combo could be 111 or 333. Something maybe, we have that one family member who has codes like that. So in this case, it's a little bit different than a combination or permutation. We're really just multiplying all 16 numbers, 16 times 16 times 16, and that our total number of combinations. So that's 4,096, which is more than if we can't use the same numbers. Okay, that is everything as far as this lesson goes. In the next video, we start to get into some concepts that are more common to Algebra 2 that you definitely, or sorry, Algebra 1 that we definitely study and show up on standardized tests, have lots of options for the calculator, and help with the fall semester of Advanced Algebra 2. So I'm excited for that. Thanks so much for watching. Oh, and you could check out that additional practice, and hopefully at some point I'll have the answers in the description for this video. Thanks.